Where are you from? NASA ESA D Jewitt, University of California, Los Angeles By Mika McKinnonan. An apparent interstellar asteroid is flying out of our solar system after being first sighted in October. Now, astronomers are trying to trace exactly where it came from, and what this brief visitor might tell us about how planets form. The asteroid, now named Oumuamua, which means to reach out from afar in Hawaiian, sped through our solar system, steeply entering from above the plane on which planets orbit the Sun. The gravitational pull of our Sun adjusted its sharply curved path, flinging it back out of our solar system at a new angle, never to return again. Some scientists are turning space telescopes towards the asteroid to continue observing this ever fainter object as it speeds away, while others are searching along the calculated trajectory to find out where it came from. Advertisement. A team led by Eric Gaidos at the University of Hawaii at Manoa calculated that Oumuamua might have originally formed in loose star clusters in the Carina and Columba constellations, both found in the southern sky. Inside the ice line for many millions of years after their birth, objects will actually preserve a velocity imprint of a birthmark of their origin, Gaidos says. This object has the same motion in space as these clusters. They theorize that Oumuamua formed within the ice line of its star, close enough to be mostly rock and not volatile ices. It could have been ejected by a collision during planet formation, sent hurtling free of the star's gravitational grasp approximately 40 million years ago. If this comes from another planetary system and it was somehow ejected when it was young and traveled all the way to see us, we have essentially witnessed a brief glance at a sample of that early planetary system, says Gaidos. This thing has been traveling between the stars in gentle bath of cosmic rays for a very long time, says Michelle Bannister at Queen's University Belfast, who observed Oumuamua. When we look at the asteroid, we learn about its original system and also about the environment between the stars. Oumuamua shares a red-tinted light profile akin to distant Kuiper belt objects in our own solar system, which may be a hint about how prolonged exposure to deep space alters the composition of space rocks. Cosmic clues. If Gaidos and his team are right, further collisions could have knocked free additional objects on similar trajectories, which means we may see more of this asteroid's cousins. The team theorizes we'll find more interstellar debris entering our solar system, along with the same steep path, akin to how comets leave behind a trail that results in meteor showers when Earth passes through it. But this, like everything else to do with Oumuamua, is still a preliminary theory where more data will be needed. Maybe this isn't its first star system flyby. Who knows, Bannister says. Given how dramatically our Sun redirected Oumuamua's trajectory, such an encounter could have redirected it enough that we're looking in entirely the wrong direction. We just have some tantalizing clues, Gaidos says. Journal reference Arxiv DOI 1711.01300. Read more. Comets may be creating oceans on alien planet. More on these topics.